Hello. In this video we're going to look at the setup for the counting of words that we're going to use as a running example. This is in the usual place for this class in the DS directory. And in the previous video we looked at the different files that are involved and how we compile. Now we're going to look starting from main in simple.c. Alright, and we're going to use this file quite a bit over the next probably 2 weeks, so we'll go through all of it. This is a file pointer that's going to be used to read data. We're going to start it off being stdin. Stdin is a predefined constant that will read from the keyboard. So what this does is if there is a command line argument, it reads from a file. So with a command line, it tries to open the file. Without a command line, it just reads from the keyboard. And when you're reading from the keyboard, the end of file is Control D. Alright. So here we have, starting with stdin, if there is a command line argument, argc is greater than 1, we try to open that file with this file name, that's a string, open it for reading. If it returns null, that means it wasn't able to open the file, and we get the error statement about not being able to open the file. Alright, so then once we're down here, we have f is an open file, we have a loop to read words, and then at the end we close. This loop here uses a function getWord, which is coming out of my words.c. So we can look at that in a second. Basically what it does is it just gets one word and puts it into S, and the len will be the length of the word. So if we actually read something, that'll be greater than 0. And then we want to put that word into an array. So here I have an array of words. I have it just predefined to be 100,000. There's room for 100,000, and my numWords is keeping track of how many do I have in there. Initially it is 0. Alright, each of those is of this type, word_t. That is defined in my words.h. Okay, so I have my word_t, which has a character pointer, a length of the string, and a count. So by declaring this like this, remember this is a global variable, I declare it, it actually has 100,000 copies of this, which are uninitialized. And I have how many of them are initialized. Initially that is 0. If I go back down into main, I use the getWord function, which we'll look at in a second, to get a word. So this string will be some word, the, it, of, whatever. I do a lookup simple, so that's checking to see. Let's go over here. So lookup simple is up here. I gave it a string here from main, so this S could be like hello or something like that. That comes in. This is a loop that goes from 0 up to numWords, however many words I have in my array here. And then I just check to see this is the word that's coming into my function. This is the ith thing in the words array. And then .w, w was the inside of the word t. W is where I'm keeping the string. Okay, so that's lookup simple. This is just a loop to go through the array, the number of items that I've used so far. Check to see is the word that I have equal to the word that's there, and to do that, those are C strings. We do strcmp. If that is 0, they're the same. strcmp is like a difference, like subtracting. If we find it, we return the index where it was found, I. If we don't find it, -1. So then here, I is either going to be the index where the word was or -1. If it was -1, we do this insert simple. And the simple, I'm using the name simple on my functions for functions that are in this file, simple.c. So insert simple is here. First I check to see if I already have more words than I have room for. I'm not going to do anything, just return. Otherwise, these two are word functions, and I'm using word in the function name if it's in the words.c or words.h. Okay, so there's some functions here to initialize a new word. It's going to go at the next spot in the words array. Words is an array. NumWords starts off being 0. So when NumWords is 0, this is the first spot in the array. It's pressing a pointer. It has the address of, so that's a pointer to, starts off being the first thing in the array, but later on it's the next item in the array. Okay, so init word does something, new word does something, and I'm passing in the word there that came from main. So that's supposed to do initialization. We can look at the code for that, and then we increase the number of words. So for dealing with our array, we have a lookup, which just does a loop through the array, checking to see each item is the word there, is the word there equal to the new, this S. So that's a lookup. For insert, we just put it on to the end. NumWords is the end, so we just initialize that spot. And then we have a print. So print, it's going to print the first however many, n is a parameter here. So if n is less than 0, that doesn't make any sense. Otherwise, I'm going to loop through the words array. So I equals 0, I plus plus, I is less than how many we have, and also less than however many they want to print. So for each one of those, we call a print word, and that has the word keyword in it. That means it's coming out of the words file. Print word, I'm giving it the words bracket I, that's one of the words in the array, and then the ampersand to give a pointer. And we also give std out. Std out is a predefined file pointer for printing to the screen. Alright, so we have a bunch of functions with word that we need to look at. But the basic structure of the program is we get a word out of the file in main. That's going to be in S. If we actually read something, it could return a 0 length. We'd have to look at the function to look about that. So if it did return something, we do a lookup into our array. That's this lookup simple. If we found it, so we return an index from lookup, then this inc word is just supposed to increase the count. Otherwise, we didn't find it, and we do this insert simple, which was up here to initialize a new word, increase the number of words we have. Okay. So what you might want to do right now is pause, browse to this simple file, start looking at main, and just say to yourself what each line is doing. So you would want to browse through and say, okay, we're starting with f as a file pointer. It's initialized to standard input, the keyboard, and then you would say basically what's supposed to happen next. All of these underscore word functions we have to look up, but I've said basically what they do. All right, so you pause. All right, on pause. Before we look at the word functions, we can just play around with this a little bit. Makes it. Now if I change this print to be 10, I will only print 10 items. And let's say I'm going to count the words in words.c. Okay, so there's the first 10 entries. They're not sorted in any particular way. There's a pound include. I could check that. Include. That looks like 5 times. What about void? Void 1, 2, 3, 4. Okay, so the count seems to be okay. Let's see what else we can do here. All right, so what would happen if I had here, what would happen if I did this? When I ask a question, you want to pause and think about it for a second. Okay, so what does this evaluate to? 0 and some other condition. 0 is false, so if I have false and something, then this is false. That means this will not happen. If I leave that there, then it's always going to do an insert. All right, if I'm always doing an insert, what will be true of these counts? Let's see. They're all 1 because I always insert the word and I'll have multiple copies. So you can see here there's include again, there's include again, and we have the H from the .h. All right, just as a test about what the stuff is doing. All right, so there's that. What would happen if I change this max words to be 10? All right, so that's the length of my array, and then later on my max words, I use it to check before I do an insert. So that would mean that I only have room for 10 items. And say I tried to print the first 20 here. But I only have room for 10, so I only actually stored 10. Okay. There's that. What if I set num words here to be, say, 100,000? I'm not going to run it. Okay, so what would happen there is when the program's initialized, the code here thinks that there's already 100,000 words. And it will start going into the words array and doing stuff. So it would go in here in this loop. It would look at words bracket 0, words bracket 1, etc. And what is there in that memory? We don't know. There's no guarantee about what's there. It might be zeros. It might be something else. So that would be bad. We don't want to look at that memory. Especially we don't want to look at pointers that are uninitialized. Okay. I think that's enough of that. We can go and look at the words. First we'll look at the header file. And so these are the functions that we have available that we'll use in simple. First we have a structure that has room for a character pointer. That's for storing the string. And we have a count. Alright, init word, we have some basic comments here. So what this is supposed to do is initialize the entries in W. W is a pointer to one of these word items. Okay, if we're initializing, what should the count be? Probably 0 if there's nothing there yet. And what should W be? Probably null if there's nothing there. This MK word returns a word underscore T star. That is a pointer. It's going to initialize memory for a new word. We'll have to look at that. Maybe we'll look at that already. Okay, let's look at init word. All right, so here we have W is coming in. It's a word pointer. I did set the count to be 0, the length is 0, and W is null. So this W is a pointer. Remember that when you have a pointer, you can take the value by doing W. And so if I wanted to set the count to be 0, it would be something like this. But I would need to put parentheses to make sure that it actually does the star W first. We have a pointer. What's actually there? I want to look at the count part of what's actually there and set it to 0. Okay, so I could do that, but it's less typing to do this. This is a shortcut. So this dash greater than, which you could pronounce as arrow, W arrow count, is just shorthand for doing exactly this. So each of those items are initialized. That's init word. Now MK word. So MK word, we make a new pointer. So if we're going to have something that's going to be a pointer, then it has to have some memory. And the function that we use to do that is malloc, malloc, memory allocation. That'll be on your list of functions you need to know. So what malloc has is it gets a number of bytes. So how many bytes am I supposed to allocate? Size of word underscore T will give the number of bytes in the structure. So how many bytes are there in the structure? There's a pointer and 2 integers. Integers take up 4 bytes. Pointer takes up 4 or 8, depending on the system. Okay, so that will give back a pointer to a new spot in memory. It returns a void star, so you always have to typecast word underscore T star. So that's a particular type of pointer. Memory, alloc, if we look at it. Okay, so if we look at man malloc, it returns a void star. That means it's a pointer, but not to any particular type, which means we need to typecast. This with parentheses here does a typecast. It converts from void star to word T under star. If there is a problem with allocating the memory, this will return, malloc will return null. So we'd have a null there. If that's the case, we just have an error message that says we couldn't malloc and we exit the program. That should never happen. That would only be if we ran out of memory or something. Right, so then this would be a valid pointer. There's not anything in particular in there, so then we initialize it. So first we allocate the memory, then we have the helper function to initialize. Now the W will have 0 counts and a null pointer for the word, for the actual string. Alright, so those are initialization. And then the other initialization function that will happen is this one. I'll put it up here. This is the order that they tend to happen. So the new word there, if we have W is allocated, it has the memory, it was initialized, now we want to put S into this word struct. So let's look at new word. Here's new word. Okay, W is supposed to be a valid pointer. I just do a dummy check. If it's null, then don't do anything. Then we want to put into S, so we'll skip and look here. So we're going to put into S, put S into W, that's str copy, to copy a string. So we copy S into the W part of the structure. Okay, To be able to do this, this has to be valid memory. And so we have another malloc, memory alloc. How much space do I need to store this string that I'm going to copy in? Well, it's the length of S, how many characters are in S. That's going to be my length that I keep in my variable in case I need it later on in my structure. L is just the length, the number of characters. So here it is, that's the length, plus 1 for the 0 byte, the null byte that always goes at the end of a string. Okay, so this is the number of characters. This is the number of characters here. And then how many bytes does one character take? On our system it's 1, but if we try to compile this on another system it might be 2 if they're Unicode characters. Alright, so that is the number of bytes that we need to allocate. So this returns a, what is the type that malloc returns? It returns a void star, typecast it into a char star, and save it into W, which the W part of the structure. Alright, so after this line right here, the W part of the structure should be a valid pointer, unless there was a problem. So we can put that check in here. And this fprintf with stderr, stderr is a predefined file pointer that prints to the screen, but then if they want to, they can redirect that to a log file or something on the terminal. Normally it just prints to the screen. But if we're printing errors, then the usual thing is to print it to std error. Alright, so if the pointer is valid, then we go ahead and do the copy. This str copy is a loop, goes through, copies each character, and I'll initialize the count to 1. That when we have a new word, we've seen it once. So this is the setup up until, let's see, when we're in insert simple over in main. Insert simple, we initialize a new word, and then we put the word in. So these are the two functions that we use. This initialization was putting a 0 for the count, putting a null for the word pointer, and then this was what we were just looking at, allocating space for the copying the string and putting a 1 as a count. Alright, let's see. So these are initialization routines. Okay, and then we have some other ones. So print word, you could pause and think, if you were a print function, what would it look like? We want to fprintf to this file, but then what's going to go in there if we want to print this word? So we could look at print word, oh, it's up here. So fprintf, we're going to print to this particular file. We're going to print the word itself, that's a %s. And we're going to print the count, which is a %i. And this %15s makes the printing take at least 15 characters, and this %8i makes that printing take at least 8 characters. That's so they'll line up nicely. So this is 15 characters, and well, this is 15 characters, and then this here is 8 characters, so they line up nicely. Alright, so that's it for the printing. Inc word, this is just supposed to increase the count by 1, and what would the code look like for that? we just want to increase the count in W. So you might think W.count plus plus, but that would be wrong because W is a pointer. Before we do the dot, we have to do the star. So this would be this would be a way to do inside of that function, but instead of doing star dot, we can always do W arrow. So we want to look, there's ink word, and there is W count plus plus. And then the last function we have is get word, which reads from the file a word, and so you might want to pause here, look through the file. This is just scanning and stopping at spaces and punctuation. All right, so we're going to read from f. fgetC is a function that reads from a file and returns a character, except if the file is done. If the file is done, it returns EOF. There's EOF. So this here, this while loop, it wants to figure out, is this expression equal to EOF, which means it needs to run this expression. It's an assignment, so that CH is going to get the value that's in here, whatever this is. So this runs, gets a character, or returns EOF. EOF is actually an integer value, like -1 or something. It's not a character. So that's why this CH is declared as an int, so that it can possibly get that EOF value. So we try to get a character, save it into CH, then the value of this expression is whatever that CH is. It's either going to be EOF or a new character. If it's EOF, this loop is done. If it's not EOF, I increase the count to say I read a character. After my loop, if the count was 0, that means I didn't read anything and I just had EOF, then it returns -1. And over in main, we have get word. So here's get word with a file, reading into a string, saves that value into length, and then checks to see, is that length not equal to 1? So whenever this length is -1, that means the file is done. Alright, so inside of the get word, we want to check to see, is this character CH, so I'm right here, I want to look at the character, is it space or punctuation? So here, if it's a space, that separates words, or if, so these are the conditions for terminating a word. I just made this up. This is my convention for this project. If it's a space, or if it's the first letter, so we don't have anything in length yet. If it's the first letter and it's not a letter, so that would be like if we had just like dot in the middle of the program, or semicolon, or underscore, or something like that. So I'm not going to count that as a word. Is basically what it is. So if either of those, that's ending a word. Or if it's punctuation and it's not underscore or quote. So if I have a word like don't, then this quote there I want to include as part of the word. Or if I have something like hello there, I'm counting that as one word. So if it's punctuation that's not one of those, I break. I stop the loop. That means the word is done. So anytime that I get out of the loop, the word is done. I'll return however many letters I saved into this S. Alright, so first I check to see, am I done based on the character? If I'm not done, then I'm looking at the putting it into the S. So S bracket length equals, I'm converting to lowercase, so all the things are lowercase. Go ahead and save the character into S bracket length, increase the length, and then make sure that I have my null byte at the end of the string. But I only do that if I still have room in my string. So my whatever this passed in is how much room is there in that string. I passed in 100. So if I get a word that's more than 100, I keep reading characters, but I only save 100 of those. Okay, so that is all of the stuff in this directory now. We've looked at all the code. So what you want to do is look through the code some more and just say line by line what you think happens and make a little note for anything that you want to ask about. In the next video, we'll look at this a little bit more and make a lab assignment out of it.